Okay, so my name is Paul Curtis. I'm with Weaveworks. And you heard Michelle talk about SMI. You heard Jody talk about service mesh and ways that they're getting deployed. I'm going to talk to you about what Michelle mentioned, which was Flagger, very specifically. So let's get going. So Flagger is a progressive delivery operator. The good thing about Flagger is that it will work with pretty much every mesh that's out there. It will perform a bunch of different progressive delivery functionality, meaning it's not just Canary. You can do other things with it. And it doesn't necessarily need a mesh, actually, to do some of those things. So if you have Nginx in place or Glue, those will work. We're all good with that. But as Michelle mentioned, it implements a control loop in the same way that Kubernetes does, in order to control how the traffic is moved between two sets of services. So as we go on, I'm going to ask everybody to raise their hand. Progressive delivery okay as a term? Oh, come on, this is service mesh. Come on, really? Okay, wow. Okay, so where does Flagger fit in the world? So Flagger as the operator does two things. It needs to talk to the Kubernetes API, and it needs a source of metrics. So Flagger by default uses Prometheus metrics in order to do this. You can see in the picture there's a lot going on here. But basically Flagger is controlling the ingress and is moving the traffic between what Stefan calls the primary and the canary. So Michelle called them version 1 and version 2. Primary and canary, same terminology. Everybody good with that so far? Okay, so let's talk about the different strategies. Is everybody familiar with all four of these? There's actually a fifth one, but does this make sense? Canary, yes, everybody knows what a canary does? Do you know where the term came from? Yeah, see, some people do. AB, the difference between AB and blue-green. Do you have those handles? And one that you don't see that often is traffic mirroring, which actually has a lot of benefits, especially in a big production world. Sorry. I just want to keep my time. All right, so blue-green. This is the Kubernetes CNI way of doing things. Okay? By the way, you'll get all these slides. So these are Stefan's pictures too. So the idea behind blue-green is very simple. It's a rolling update. Okay? It says that if I have 5 pods of version 1, I'm going to cross over and roll in 5 pods of version 2. Right? And the way that typically happens is over time you can control it, but fundamentally it's a manual process to you. AB. This is kind of the old insiders trick. So you deploy version 2 or the secondary, and you let some people try it out. Right? So this half of the room gets A, and this half of the room gets B for some period of time. When everybody's happy that everything is cool, then I'm going to switch and make version 1 the old version the new one, so version 1 to version 2, and then I'm going to get rid of my old pods. A lot of times this is done with special features, like I added a URI or I added a service, and I'm going to test it with a small segment of my user population. So far, so good. Everybody makes sense? Does everybody understand the difference between this and a blue-green? Please raise your hands. Wow, that's much better. Okay, that makes me a little happier. So now we get on to the fun. Everybody loves the canary. All right? The idea behind a canary is very, very simple. A canary is going to progressively move traffic from the primary to the canary over a period of time up to 50%. When it reaches 50%, it will then be able to make a decision to move all of the traffic over and make version 2 the new primary. Does everybody get that? No problem with that question, right? Good. So, two things you have to keep in mind with a canary deployment versus some of the others. First off, in order to make this work, you need to have some metrics. You need to have a general idea of how you want this to work and what the time is, okay? You also need to be able to see what happens as you're doing this progressively. See, an A, B, or a blue-green, it's like a Frankenstein switch. You turn the switch, and it's either going to work or it's not going to work, and you're going to know real quick. You still should probably have some metrics, okay? And the rollback is basically a one-shot thing, right? Just turn it off. Canary, the idea is you're trying to make this seamless. You're trying to present the service in such a way to where it never appears to be down to the end user. And the whole idea here is that the user doesn't know that you've shifted versions, that you've gone from primary to secondary. The whole game here is to make this seamless. Now, what service meshes can do a Canary out of the box? How many know? Right? Istio can do it. Who else? Linkerd can do it. Some others as well. Right? The last deployment I want to talk about is mirroring. And this one's not as common, but this is a very, very simple way to do this because it gives you an advantage that A, B, and blue-green don't. All right? Same idea. You have a primary and you have a secondary, or a version 1 and version 2. All right? So what you're doing is you basically deploy version 2, the green. You test it, okay, make sure it works. And then you mirror the traffic so that both the blue and the green, version 1 and version 2, are getting the exact same traffic. All right? Now, that means that is like, you know, trial by fire for version 2 because he's going to get the full load of everything that the current running version is getting. Okay? The good part about this is that you're going to know real quick whether version 2 is going to hold up or not because it will either run or it will die horribly. Okay? You also collect metrics across there so that you can keep track. For whatever reason, the reason you deployed version 2, but you want to keep track of the metrics, make sure it performs okay and there's no big problems, validate your service levels, okay, make sure everything's okay. And then basically, you move version 2, the new version, into version 1, and you get rid of the original pods. Okay, that was the 10-minute introduction to all progressive delivery. Are there any questions? Does everybody get this?
Yes.
Yes, thank you. Okay. Good, I know it's afternoon and it's about snack time and everybody's starting to fade. Okay, so what does Flagger do? All right, so Flagger is an operator, as I mentioned, and it's been simplified over time. Flagger's configuration and operation is using GitOps. So fundamentally, a thing that Weaveworks pushes into is using Git for all configuration and source of truth. So on the left-hand side here, even with everything that we've been talking about and you've heard earlier today, if you wanted to go out and actually do a manually, by hand, create a Canary and run it and deploy it, those 6 and then 4 are the things that you're going to have to create. All right, so think about it. Assume you have a pod deployment out there. You have to create the Canary. You have to create the IP service for it. You have to make sure it's deployed, okay? Now the Canary has to have its own set of IPs, its own HPA if you're going to use it, and its own deployment. So now what you basically have to do is create all that YAML to do that, or copy and paste it, or whatever. Now let's go down to service mesh. At minimum, you have to have 2 sets of routes, okay? Because you've got 2 completely sets of 2 deployments. You have to have the rules that you're going to implement for how to do this, and the service mesh has to understand how to do it. Right? Because the Canary is not like all or nothing. It's like 1, 2, 3, 4, 1, 2, 3, 4, like that. So this mesh has to be able to handle the fact that it's going to shift traffic under control back and forth. You need all the virtual services to do this, right? So there are going to be a primary and a secondary service. So all of this stuff here on the left gets to be timing out on the screen display, right? There's all these things. Now, if you go over to the right, Flagger's Canary consists of two things. You need a deployment, some kind of deployment. And by the way, Flagger uses the name of that deployment. Okay, so keep that in mind. So you do have to tag and do proper naming in your deployments. And it needs the Flagger Canary object. And that's it. That's all you have to do. Pretty magical? Okay. So what's the CRD look like? All right, so this is going to be a little hard. I'm going to actually step down because it makes it a lot easier if I do this. So there's two parts of what you're looking at. On the left-hand side, you have a very good idea of what this looks like. Does everybody understand what's going on? When I said the name of the deployment is critical, it's because the metadata pod info name is how it does the hookup. That's how it finds it. Okay, and the target is the other way. It needs to have them both. The bottom, if you use an HPA, does everybody know what an HPA is? Horizontal pod autoscale, right? Fine. Okay. Is an option. Don't have to do it. Okay, if you're pretty confident that your deployment's going to be cool and it's not going to go running wild, then it's up to you. Flip side of this, on the other side, okay? These are the beginnings of the things that you need to make sure that how the Canary gets run, what it is looking at, and the routing for it. We're going to talk a little bit more about how the thresholding works in the next slide. I'm trying to keep you awake. Okay? Is this clear to everybody what we've done here? So we've defined the targets, and we've defined the routing for those targets. Now, what is happening underneath is very nice. So Stefan has made this such that this CR will go ahead and do all of those things in this list on the left on your behalf. Okay? So if you think about what has to happen, is the only thing that you have to tell it is the routing and the pod info, basically. The only other requirement for this to work is you have to have Prometheus. We have to have some way to get metrics. Is that clear? No questions. We like that. Okay. So now how do you do the analysis? This is even more fun. And I did ask a question of Stefan when I did this. So Canary works on a time, okay, and a step interval. Right? The idea here is that over a certain amount of time, I'm going to shift the traffic by some fixed amount from the primary to the Canary, or from blue to green, or primary to secondary, whatever your terminology is. And it is your choice as an application developer or an operator to figure out what those numbers are. Now, how many have done this in production? How many have done Canary progressive deployments? Ooh, 1, 2, 3, okay, 5. In a room of 100 people? Okay, so this is not cutting edge idea, but it's something you have to think through. And I'm going to give you a reason why I want to talk about this on the left. My background is a developer. So I need to think about something very simple. What interval do I feel safe to ramp up my application? Because a blue-green or an AB, I mean, it's pretty much, it's all or nothing. It's a binary thing, right? In doing progressive delivery in this way, I get to be able to do two things. It's kind of like everybody's flown a jet, right? Okay, you know what they do right at the beginning of the takeoff? Right before they actually floor it. Do you know what they do? They take the engines to 50%. And they let them. You hear them. They spin it up. You know why? They want to make sure everything's okay before they hit it and make it go to 100%. This is the same idea, and it has the same results, but you got to know what these numbers are. What's a reasonable criteria for you? Now, there was a production one, a couple of people in production. Can you just tell me what your interval time was? I'm just curious. There's somebody down here. What was the interval? How long did you go from 0 to 50% in your Canary? Do you remember? Right. I want you didn't hear that. It's just like, depends on the service. Yes, absolutely true. He said, one runs to 1 week?
Yeah. Sometimes like monitoring or tracing, not the impact we can show.
Right.
Yeah, sometimes 1 day or 2 days. Yeah.
There was somebody else down this side. What was yours?
Between 2 and 5 minutes.
2 and 5 minutes. 1 week, 2 and 5 minutes. Okay? Do you think the application services they were testing are exactly the same? Probably not. I came out of the big data world. We would do this for prediction models, would be an hour to 2 hours. So that we would know that if the correlation rate was going off in an hour, like we were, telling the lady to buy carrots when she was looking for pantyhose, probably not a good recommendation. Okay, we would roll it back. But it takes a certain amount of time for that application to ramp up in order to do this. Okay, so does the other two numbers there, max weight and step weight. The max weight is, remember our diagram? How much traffic goes to the primary and how much goes to the canary? That's what that number is. 50% goes to the canary. We're never going to turn 100% over. All right? This is pretty much a given. The step weight, every increment that it increments that progressive delivery, that's that number. So over a week, your step's probably going to be pretty small, like 1%, maybe 2.
Some service very scarce, so they just use it a long time to test. Then later, I think the service team has more confidence.
Right. So there's another one. Where you do this in testing, there may be a reason where that interval is very long and the step is very small. But when you get more confident with your testing, you can shorten the interval and up the step so that it happens quicker. But each step is something you want to monitor because you're going to want to see what happens as each step goes on. So don't make the interval too short because otherwise you're not going to have enough time to get any metrics out of it. Okay, now on to the other side. Flagger has a couple of nice features and a couple of ones I really, really like. Okay, the first thing is that Flagger will look at thresholds, and the thresholds can be based pretty much on any standard service mesh metric. Right? The service meshes report a lot. Okay, the key one just on these two is, right, does everybody know what red metrics are? Ever heard the term? No. Okay, there's a couple over here. So service mesh reports request, delivery, error rate, and duration. Red, okay? That's 2 of the 3. You can put the third one up here as well. All right, but that's a very standard way to view a web-based service or a REST API service or something that uses standard networking connections. So red metrics, very, very simple. But in my world, coming out of big data and model testing, red is okay, but it doesn't tell me if the model is actually doing anything useful. Right? So there may be application-specific metrics that your developers put in that are things that they know about their application that are critical. And in the model world, it's called correlation rate or error rate, hit rate. Okay, things like that, that says, I want to make sure that my correlation rate always stays above 90% and my errors are below 2, right? Because I don't want the model to do something really stupid like send carrots to the pantyhose buying lady. Not a good plan, right? So to do that, you can put in other types of metrics here. Anything. What do these do? So just to give you a general idea, request duration, request success rate. Let's do the first one. It says I have to have a success rate of 99% over the course of a minute. If it goes below that, if it goes to 98% in one 60-second interval, I fail and I begin to roll back. Now, understand what this does. Flagger reverses the process, goes backwards. So if you're at 45% and you hit an error rate that's too high, it goes 40, 30, it moves it back, okay? That way you don't get this like kind of, Frankenstein monster switch thing going on, all right? So it will progressively roll it back, or abort the canary is the term he uses. Yep, got my clock. So the last thing here with Flagger as well, as Michelle mentioned, somebody really likes this, is you can actually put in webhooks to have it do stuff. So for example, if you want to actually have it start up a load test, if you have a service that isn't under great load, or you have a very specific set of corner cases you want it to do, right? When you start the canary, you can say, hey, go do this. This should be very familiar syntax to anybody who's done like pod spec, okay, basically. That one's really powerful because what it means is that not only can you do progressive on real traffic, but you can also throw errors in to make sure that the canary is good before you let it roll out. Okay, last thing. These are the kinds of things that we're looking for. This is basically a summary of what I just said. So the canary also keeps track of some of the basic stuff. So everybody uses liveness and readiness probes, right? We all nod, very good, okay. So you use red metrics here as well. Custom metric checks, Prometheus queries. So anything that you can get in PromQL, you can turn into a metric. And if you go to the how-to for Flagger in the documentations, actually has a nice little example. So you could do things like error rate or percentage error rate or rolling average or any number of those kinds of things. The last thing is the webhooks are actually kind of cool because what it means is that you can, in a test environment where you may not be running a Kubernetes test or dev cluster that has real traffic, like it's not the real system, but you want to still do a progressive, like a canary test, you can do this in QA, right? And all you do is you use the webhook to generate traffic, right? Remember traffic mirroring back in the beginning? QA is a perfect place to use traffic mirroring. How do you get traffic mirroring, right? You can just turn it on. So there's a lot of ways that you can use webhooks and get sample traffic, generated traffic, or mirrored traffic in order to do your testing. Obviously, Flagger has a bunch of built-in stuff, but for the most part, alerting is kind of done nicely. Email's obviously one of the choices, but the real-time alerts, Slack and Teams, seems to be pretty much the common. So now I'm just going to, for the last minute I have, is to talk about what this looks like in a whole GitOps pipeline. So GitOps, for those who don't know, is a method of using Git as your sole source of truth for declaring what's in your clusters. I'll point you to a talk if you're interested in hearing about it. But basically, the Flux utility does that, makes the cluster the way you want it. Flagger works very well in this environment because it uses the same GitOps methodology, right? Everything you declare for Flagger to do is declared in Git, okay? You can roll it back, you can use the past one, and once the canary is deployed, Flagger will update the Git repo with the correct new primary images. So it'll actually keep it up to date. So it makes it very simple to do. If it's unsuccessful, obviously, it's not going to do much with that. But if it is successful, you'll be able to know that, and you'll be able to see it up front very, very quickly. And I wish I had that clicker thing. This also works with Helm. So Flux works with standard manifests, any Kubernetes object. You can throw Helm charts in there as well. We kind of like using Helm. Okay, process is the same. The only difference in that picture from the one before is Flux is using Helm. Now, here's the key slide. Right, everybody get your cameras out. Okay, so the repo's at the top. Okay, a nice discussion of Istio as an example. A nice one with Flagger and Linkerd. And down at the very bottom with AWS App Mesh. Now, as I said in the very beginning, the App Mesh is new. Okay, that was just added to Flagger. So that's something that's fairly new to what we're doing. Stefan Proden, who actually wrote this, is actually around. He is not here today because he is over at AWS giving the exact same talk. Okay, so 2 things. Our booth number, come by. We have this interesting little contest that you can do on your own time. And lastly, I recommend for people who are interested in the GitOps methodology and using declarative source code control for controlling your clusters, that is the talk to go to. Okay, it is on Wednesday. Now, before we go, since I've got exactly 30 seconds, does anybody recognize that ID? That is my ID, one of my IDs. Does anybody in this room raise your hand if you recognize what company that's from? Netscape Communications, yeah, that's Mozilla. Back on the thing. So thank you very much, and we'll see you at our booth tomorrow.